You're listening to The Local Maximum, episode 248.
Time to expand your perspective. Welcome to The Local Maximum. Now, here's your host, Max Sklar.
Welcome, everyone. Welcome. You have reached another Local Maximum. I had a great weekend. This weekend, I was actually in New York, and one of the things that I did in New York was I went to a reunion or a meetup for Yale Radio WYBC. As you know, I was, not as you know, I mentioned it a couple times on the show. I'm not going to assume. All right. I was on Yale Radio when I was there back from 2004 to 2006. And I had a show on there called Max and the Wiz. And so it was one of the best things that I did in college. It was really a lot of fun looking back. Every other activity was like kind of real stressful. This was kind of a pleasure. And it was really nice to meet people who also did radio in college, who also did Yale Radio. And I got to meet people who worked in all different eras of radio. So, for example, people from the who were doing it in the 70s and 80s, who were dealing with 8 tracks and records, and people, artists and musicians were coming into the office to try to get them to play their records. I don't think anyone actually comes in anymore. Down to the 90s where you were really doing, where then all of a sudden you had CDs and tapes, and my era. Interestingly, in the 2000s, I learned a lot about my era of technology and radio. It had a mix of streaming because we did have a streaming service showing off, what I was saying and all that. And it was also over the air waves in New Haven and the surrounding areas. It reached as far west as Fairfield, Westport, and it reached as far south as points on Long Island. My era had a mix of streaming and over the airwaves, and people would call in. And not only would they call in, they would also talk to me on Instant Messenger. We didn't have Twitter at the time, but we had AOL Instant Messenger, and I actually I had a specific account, a specific handle just for the radio show. I think it was just called Max and the Wiz, and people would message me on the air while I was live. And, you'd have that interaction that way, and we saved music and recording on CDs. So that was my era. I actually, now that looking back at it, I like my era. Now on the radio, on Yale College Radio, and I think a lot of them, it's streaming only for the undergrads. And that's what they tell me is this is a lot harder to get listeners these days because there's so much content out there. People aren't tuning in on the radio. We had kind of listeners built in because there are people from the New Haven and surrounding areas who would just kind of turn on the radio and listen to us. It's harder to get people to listen to your stream, especially these days when there's so much available. So maybe I should do an episode on that in terms of the history of the radio or music technology or radio technology that has been used over the years, and how things are like today compared to how they used to be. We definitely have done shows on the future of audio, and maybe I'll post that up because I think it's actually been a while. If I go into the archive here, I can get audio, the audio internet with Shani Offen. That was an interesting one from back. That was a pre-COVID episode, so maybe I'll look at that. I think kind of the progression of technology in that particular field. Very fascinating stuff. All right. So that's not today's topic. That's just a possible future topic. Today's topic is a little different. There's this big puzzle in geolocation going back centuries and centuries in terms of finding the best way to pinpoint locations and regions on the globe. And so you can go back thousands of years to the ancient Greeks who came up with geometry to try to figure out, how to survey land and how to try to pinpoint, how to do navigation. And then you had, during the age of exploration, I think it's during the age of exploration is when they came up with latitude and longitude coordinates. I don't know off the top of my head who came up with that. I'm guessing it's Descartes or someone around there. So latitude and longitude coordinates are great to pinpoint any point along the globe. And then there's this idea of projections. So can't carry around a globe everywhere. So you want a flat projection of the Earth onto a map. You might have heard of the Mercator projection and the whatever projection, but that is also an innovation. And now in the digital age, we have to come up with all new types of ways to pinpoint points on the Earth because there's so much geolocation data out there. Foursquare, for example, has a lot of points of interest, a venue database. And so you have to figure out how to organize that. Like, yes, you could just have venue and latitude, longitude, but there are better ways to organize that and to visualize that than there are before. And you also have regions, land and water, roads, regional boundaries, property boundaries, all that kind of a thing that goes down to the really, really small level. There's weather data, there's movement data, all that stuff, from urban data science. So I've used S2, for example, which is a framework which actually projects the world onto a cube. If you think of it this way, if you think of the Earth and imagine a giant cube encases the Earth. And then from wherever you're standing, you look directly up. And when you look directly up, that's the point on the cube that where you're standing, it's projected onto. And so that each face of the cube is a admittedly huge 1/6 region of the Earth. And then each face of the cube, each square gets broken down into 4 squares. And then each of those 4 squares get broken down into 4 squares and so on and so forth as you go down, however many levels you want to go down. So that actually helps a lot with making search efficient, and it helps a lot with kind of trying to figure out how to describe regions. I mean, you could just describe regions as maybe latitude, longitude points that encase it, like a polygon. But if you actually have the pieces or the squares that are inside of it, that allows you that enables you to search that region. And because it's hierarchical, it's very it's very efficient. So that's really good. So there's this new innovation in this area of tech, and the innovation is they're using one of the things is they're using hexagons instead of squares now. So why hexagons? Hexagons seem a lot more complicated than squares. Why are they using hexagons? Well, we're going to find out today from Isaac Brodsky, who co-founded Unfolded, which is a geospatial analytics company working off the open source library H3. I assume the H is for hexagons. We had a really fun conversation about geometry and software. Also, look out for a new terminology as well. For example, you've heard of the Bermuda Triangle. Now there's a Bermuda Pentagon, not a Bermuda Hexagon, a Bermuda Pentagon. Why is that? So I hope you really like this conversation. It's not just, this is the kind of stuff that really gets me going because I've been into maps all my life. I've been into I've done so many projects in geolocation, but it's also, it's not just to talk about software, it's to talk about geometry and math and how to organize the world. I think that's really fascinating. So I hope you enjoy it. All right. My next guest is a principal engineer at Foursquare. Isaac Brodsky, you've reached the local maximum. Welcome to the show.
Hi, thank you for having me.
It's really fun to have you. I haven't spoken to someone at Foursquare. Well, I've spoken to people at Foursquare, but I haven't had someone from Foursquare on the show probably for, I don't know, a year and a half, 2 years. So I really appreciate it, and I'm really excited about this conversation today. But first of all, let's get a few things straight. So you've been at Foursquare for like a year. You came in tell me how you came to be at Foursquare, because you had the startup on Unfolded and all that.
Yeah, so the story for that starts a few years ago. It's kind of funny to come on the show, and normally I have to explain more about Foursquare, and it's kind of the inverse here, where I come on the show and I feel like I should be asking you, tell me about Foursquare.
Well, I'm happy to get into that if you want.
Sure. So let me give a little bit of my background. That started a few years ago at Uber, where I was working on geospatial data systems. I was working on their marketplace data team. So we're looking at economic indicators of like supply and demand in these Uber marketplaces. And because Uber is moving people and food and all sorts of things around these markets, they have a really strong focus on the location of those ride requests or of restaurants or all the things that they're tracking. So we were working on a lot of different really advanced geospatial technologies there. I was working on H3, this hexagonal grid system. Some of my colleagues were working on visualization systems and data systems and how we use this data in data science. We reached a point where a lot of the stuff had been developed as open source. And as Uber was going public, it was kind of clear that like their priorities were shifting, but we were still really excited about these technologies and really excited about continuing development. So around the end of 2019, me and three of my colleagues co-founded Unfolded, and that was the startup you mentioned. So we were building Unfolded Studio, this geospatial data analytics platform. And we were doing that for about a year and a half or so. And then, like you said, the middle of last year, so this is about a little over a year ago now, that merged into Foursquare and joined it to Foursquare. And so there was a few months overlap there where we were both in Foursquare, but I was just getting.
I remember when it happened, and we actually were using Unfolded for some visualizations before you guys came in. So I think
that's exciting.
2019, maybe. Yeah, even 2019, I think so. I could be wrong.
So that would have been pretty early usage of Unfolded, actually.
So maybe 2020.
No, that's exciting to hear, and it's also been great to see how some of the open source technologies that we've been working on kind of throughout that time, and even before that, have been picked up and used throughout industry. It's always fantastic when you talk to somebody. They say, "Oh, I was using H3 or Kepler or some of these other technologies we were working on."
Yeah, so I want to get into those in a little bit, but first of all, like how did you come to be interested in like geospatial technology? Was it just you were at Uber and that was your job, or did you have a particular interest in it that kind of made you gravitate toward Uber and things like this?
It's a little bit of both. So when I came into Uber, my feeling at the time. They were saying, "Oh, well, we'll have you do work on these data systems." And I was, pretty new engineer at that point, and so I was just like, "Okay, I'll work on these data systems." So a little bit of it was kind of the job, and then there was some part of it which was after I got there, I was kind of looking around at what we were doing, and some projects like H3 really stood out to me, both because they seemed really fundamental to what we're doing, because it's how we actually know where things are going on in this market, and it's also really cool technology. There's all these fun geometry aspects to it, and computer science encoding aspects to it, and things like this. So that seemed like something that I really wanted to be involved in, and those are kind of the two things that really drew me to that and drew me to continue working on that.
Yeah, so H3, I want to get into. Why don't we get into H3 now? Because the geometry of it is really interesting. I see all of these maps with hexagons and stuff like that. So why? First of all, the fact that it's hexagonally based, and I want to talk about how that actually works in a bit. But was that a design decision that you made early on? Was that a design decision that was kind of decided on beforehand? Were there a few different iterations? Why hexagons?
So hexagons were a fairly early choice in that, and that decision did predate me. Hexagons were known to be something we wanted to work with for kind of these abstract mathematical reasons of how each hexagonal cell relates to its neighbors. And because we're dealing with movement in the real world, and that movement characteristic is also useful for other stuff, but movement is a good way of explaining it. If you're moving around on this grid and you're looking at a grid of hexagons, every hexagon that you can move to from the the hexagon cell that you're in is an equal distance. And if you look at like a square grid, this isn't really the case because there's 4 neighbors that are sharing an edge and 4 neighbors that are sharing a vertex, just a point. And so if you move in a diagonal, it's not quite as good a quantization of your movement. So this was kind of the like abstract math reason for we wanted to work with hexagons. There's also a little bit of a reason of just it kind of looked cool, and you could build it into a little bit of a bee theme and like have some fun with that. And we shouldn't discount that it does look cool, but the math reason was kind of one of the driving forces of that.
So I'm trying to wrap my head around it. Can you give me an example of like, okay, let's say I'm moving through the world, and if I'm moving through a grid, it's fine. I could still list out all of the squares that I move through, but what's the benefit? I mean, I could see there's probably some weird things that happen with the squares where like if you come very close to a corner, then you'll clip one square very briefly. But is there like a specific like reason other than that why the hexagons are better?
So I think the other way of looking at it, that's one way of looking at it is if you're moving through this grid and you're leaving this trail and we want to record what that trail is. I think with hexagons, there's some like academic papers which can kind of explain this better than I can in terms of why that's better from a quantization standpoint. But I'll just say that those papers are out there. If you do
send it, please post it. We'll post it on the show notes page. But
I'll see if I can look it up. But the other way of looking at that is kind of the other side of looking at a marketplace. So you might have a bunch of locations that have restaurants in them, let's say. And if you plot these on the map, you have a bunch of restaurant points, but these are all just individual points. Let's say you instead want to look at the concentration of restaurants in particular areas. Now you want to start aggregating them into some kind of geometry. And let's just say you want to use a grid for that. And you might want to look at what is the grid distance between me and like the nearest cluster of restaurants, the nearest grid cell that has a large number of restaurants. Suddenly you start having uses for that hexagonal shape because it better approximates a circle. And so you can very easily do these kind of smoothing operations and expansion operations, contraction operations on the grid itself. So you're no longer working with these like very messy coordinates and very messy like exact locations, but instead you're working with the grid as a little bit more of an abstract representation of what's going on. And when you have that, having that hexagonal shape makes some of those operations, like I said, like smoothing, or you can think of it as convolution or kind of a few different names, become easier on that grid.
Yeah, so it's that kind of reminds me how so we used to use S2 cells at Foursquare, which are grid based, and for all I know, we still use them on the consumer apps. I'm not sure if they've moved over to. You might be able to tell me more than I know. But we did make like kind of cool visualizations of different neighborhoods. Like we'd have what's the highest ranked photo in each square or something. But you definitely get cases where like a square would kind of clip a small piece of a neighborhood. And I guess that could still happen with hexagons, but I feel like it's less likely to have, I feel like it would be more representative.
Yeah, it's a really interesting comparison because I think the H3 and S2 systems are very comparable with relatively smaller differences. I mean, the shape of the grid cell is a pretty major difference. All things considered, it really changes how you look at it. But it's a good example that you can do a lot of the same things that I'm talking about with square cells. And for all I'm very positive and optimistic about hexagons and about H3, I also try not to come across as too salesy and try to tell people like, oh, you can't do this with squares or things like this. It's like a lot of this stuff you can figure out a way of doing it with other geometries. There's a lot of technical decisions we can make, a lot of engineering decisions we can make. So I don't try to tell people like, oh, you can't use squares. I'm sure there's still S2 being used around at Foursquare. I haven't gone around and convinced every single engineer to use H3 yet, but I suppose we'll get there eventually.
Also, the fact that admin pages can be quite long-lived, if you know what I mean. Like there could be stuff we built 5 years ago still in there. So, I mean, the other question that I have written down here in terms of the squares versus the hexagons, with the squares, it seems like, okay, each square can be subdivided into 4 squares, and okay, you're like, oh yeah, that's 2 bits. Now, subdividing hexagons is a little bit more is tricky, is it not? And I feel like you guys have probably solved that, but maybe you could talk about that a little bit more.
Yeah, so we've solved it for some amount of solving it. So if you think about a square, like you said, it can be broken down into 2 or to 9 squares, and it's fairly easy to see in your mind how that would work. With hexagons, you don't get exact subdivision, and it's a trade-off that you have to live with in the H3 library. If you're going to be using hexagons, then this is a trade-off that you have to make, and you have to find some way of dealing with. The trade-off that H3 uses is it subdivides the hexagon into 7 finer hexagons.
By the way, this is the moment of the show where we have to not have a whiteboard and try to explain it, which is all I could say is good luck.
Yeah, there's some online resources. If you go to h3geo.org, I think some of the notebooks are linked there, which kind of visually shows this.
But sorry to interrupt you. I do want to hear it, so let's give it a shot.
Absolutely, it's certainly better with the visual aid. So I'd encourage if you have a chance to look at that, please do. We subdivide a hexagon into the 7 finer hexagons, but they don't fit exactly into that parent cell, into that parent hex. And so what happens in the library is they get kind of rotated one way and then back again each time you do this subdivision. And this produces kind of a fractal shape around the edges of the cell as you're doing the subdivision. So this sounds kind of scary because you have these areas that are being essentially areas that are in error where the geometry doesn't align with the index.
Right. So first of all, actually, let me try to say, just for the audience, I feel like what we're talking about is, these hexagonal tilings aren't just one level, right? There's different levels where the hexagons get smaller and smaller and finer. And whereas in the boxes, if the boundaries are exactly the same, with the hexagons, they're a little bit different. Like I might be in one clump, but then when we go down a level, I'm in kind of another clump.
Absolutely. So I probably should have mentioned that a lot of this class of systems is called discrete global grid systems. And that's one of the properties of it is you have this hierarchical relationship between one level of the grid and the next level of the grid. And that property that you just mentioned, where when you move between resolutions or levels of the grid, you might wind up in kind of a different part of the indexing structure, is one of the trade-offs of H3. In practice, there's a lot of things you can do that don't wind up with this problem. So it is possible to work with this in ways that are a little bit more exact and kind of avoid some of this. For example, if you're just working with one resolution of the grid, then you're automatically fine because none of this applies to you. I think a lot of the other cases that this comes up is when you're trying to optimize like visualization of what's happening in the grid. And that's a case where you kind of have a little bit more tendency to run into trouble of trying to draw these like overlapping hexagons. But you can still represent the data in a consistent and correct form. It's just that rendering it is a little less performant or is a little bit more complicated to do.
Yeah. So, okay. Another question I have with the hexagons, and this is a problem for squares too. How can you tile the whole Earth with hexagons when hexagons tile a plane?
Yes. So we say that H3 is a hexagonal system, but there's actually supposed to be a little bit of an asterisk after that, which says H3 is a mostly hexagonal system, except for the parts that aren't hexagonal. So squares, you can tile the world with them. It works out, you project the world onto a cube and you subdivide everything. With hexagons, unfortunately, the math doesn't work out. So the solution that H3 uses is we have 12 pentagons at every resolution of the grid. And these pentagons were chosen to be placed into water. So the idea was like if you're using them mostly for land use, like for a lot of stuff that people are doing, it tends to be on land. So putting them in the water is kind of an out of the way place to put them. But you're right, in order for it to be a fully global system, it does have to have these exceptions. And
did we just get lucky that the land on Earth is in the water on Earth is in certain places that the hexagons can be placed, or the pentagons can be placed in the water? Is that just
pretty much? Yeah. Yeah. It's I think the margin of error is like maybe a few miles for the one that we're using. So there's actually kind of an interesting history of this. That this setup of where to place these pentagons was discovered by this guy, R. Buckminster Fuller. And he worked out how to do this. And for the longest time, this was the only known set of points that you could use for placing these 12 pentagons all into water. And very recently, there was some other work that somebody found there were other setups that work, but for the longest time, for decades, I think, there was just this one that was known.
Interesting. So do you know where they are? I mean, not that I don't know if I
know where some of the closest ones are. So there's one that's near like Washington. There's one that's I'm not sure if it's actually in the Bermuda Triangle, but we call it like the Bermuda Pentagon. It's kind of off in the Caribbean. There's one off the coast of I'm going to mess this up, I think, but I think it's Norway. One off the coast of like I think it's between China and Korea. So I kind of know where most of the ones that tend to come up are, but sometimes I just look it up.
It sounds a little bit like a soccer ball of some sort. Like how many pentagons are there?
So there's 12 pentagons, and it is the same geometry as a soccer ball. So a soccer ball, I think, has fewer hexagons than the H3 setup does. But the H3 setup and the soccer ball geometry, I'm not sure what the correct mathematical term is, but there is a relationship there.
Okay, cool. So let's that was really cool geometry stuff, but let's get into like the visualization stuff, which I think is what most people want to hear about. So what's let me just ask, like, what's your favorite visualization? Oh, wait, first of all, before we get in that, what's the difference between H3 and hex tiles? Is hex tiles for the visualization, or actually explain to us what hex tiles is?
Sure. So this is something that's we started working on years ago at Unfolded before it had joined into Foursquare. And since then, Foursquare has been able to release, which I'm really excited to see. So H3 is an open source system. It's out of the public. Hex tiles is something proprietary that we've built on top of that. And it was created because of this problem that we were noticing when working with geospatial data, which is we loved working with this H3 data. We thought it was a great way to work with the data, to analyze it, visualize it, all these things. But when we're transferring thousands, tens of thousands, hundreds of thousands, however many data points from like a server to a browser in order to visualize it, things were starting to slow down. We were doing kind of the standard stuff at the time, using like GeoJSON or CSV or something like this to transfer it back. And when you're starting to work with a very large number of data points, this starts to be just a huge problem, slows things down, makes it very difficult to work with the data. So Hextiles was really created to address this problem of we want to work with large data in this same grid methodology we've been talking about. And so to me, it's a way of getting the data back to an application or to a browser to visualize it in a way that is much more manageable. We break it down into these hexagonal tiles, and we send that back to the browser instead.
So, okay, so let's talk visualizations. What's your favorite visualization? Was there like maybe we could do one that's like newer and one that's like, what was your first like aha moment or holy shit moment, when you were developing this?
Like visualizations we've made with Hextiles or Folded. Okay.
Yeah.
Let me see. So I think a few that I've really been excited about or impressed by. One is just kind of a favorite of mine is I've made a few maps now that are, instead of elevation maps, they're steepness maps. So this is, instead of looking at where you are, elevation wise, it's kind of how much is the steepness of that area, what's the grade of that area. And for walking around in like the Bay Area or something like that, if you're on foot, we don't have huge elevation changes, so it doesn't really matter exactly where you are. I'm not walking up a mountain or something, but you might know San Francisco hills are like quite infamous for being very steep.
Sure.
So I like having this concept of like what areas are steeper or not. And I've had a lot of fun just like building some of those maps and looking at them. I don't use them quite as much as I should for planning where I'm going or what I'm doing, but I just find it a fascinating map. And it also is easier to make when you have a grid system like H3 because you can look at the difference between these cells and see how much these cells are changing. Another kind of set of maps and set of visualizations that we've made that I found to be pretty impressive are some of the weather ones and climate ones. Because we have the ability to bring this data in across a really wide geographic area, so maybe the whole United States or across the world or something like this, we can look at weather trends. You can kind of do the cool meteorological map of where the clouds are moving, where the rainstorm is moving, essentially. And as you look at different aspects of this, you can still see these patterns emerging over time as things are moving through. And I just find that to be a really fascinating set of maps to look at. For one thing, it's technologically complicated to do that because you have to have a lot of data. But on the other hand, it's also very just visually and curiosity-wise engaging to look at as you see this kind of natural system moving and changing, and you can kind of see geologic features that are shaping movement and things like that. I just find that really cool to look at as well.
Right. So it's almost an alternate way to see the weather maps that we get. I think that'd be very interesting.
Exactly, yeah.
Of course, these days looking at the, I don't know, you've been kind of glued to the TV with this hurricane, but, I feel like this could be used to model that kind of thing.
Yeah, I mean, it's
or visualize, I should say, not model, but yeah.
it could certainly be used to visualize it and also to bring in that data for other analytics. I mean, it's a particularly striking example because that's a it's a severe weather event and it's really affecting people. So that also kind of connects what I'm talking about to you can use this data for something because people very much care what is happening in severe weather in hurricanes and fires, things like this. I mean, it's a great example that this is also important data.
Yeah, and another reason why you want these things to run efficiently, like with hex tiles, it doesn't take so too long to get it up and running. What about at Foursquare? Have you guys made any visualizations with the Foursquare data yet?
So we absolutely have. We've looked at some of the Foursquare data products. We have data products around, as I'm sure you know and could probably explain better than I could, around commercial measurement and kind of this concept of foot traffic, as well as around the density of, or I shouldn't say this, but I should back up a second and say around places of interest and what is the actual ground truth in a city? Where are the restaurants? Where are all these different places that people care about? Where are all these businesses that people care about? So this is also data that can be taken through this analytics journey, this analytics pipeline. When we're looking at, let's say, what areas are particularly dense with restaurants or with different types of venues. That's of course something that we can aggregate into a grid and we can provide for analytics purposes. And if we want to look at how are those venues doing, how are those restaurants or stores doing over time, that's again something we can bring into this analytics pipeline. And when we have these and other data sets available to us in this grid system, we have this great opportunity to bring them back to the browser and show you, of course, what's happening in a city, in a market. What are some of these things that you care about? And then also use it for analytics purposes. So if you're trying to do some kind of enterprise plan where you want to place a store or where you want to invest in in different businesses or real estate, things like this, you have access to this information and you can bring it into your analysis.
Yeah, that's cool stuff. We also used to do a bunch of stuff of like, the flow of people, where people are going, where people are likely to go next, how many people go from Brooklyn into Manhattan at a given hour, that kind of thing. So I feel like it would be good for that as well. Do you have like a dream use case for this technology that you've wanted to see for many years and just hasn't been built yet?
Well, this is a bit of a dream, and it's a little bit disconnected from the other stuff that we've been talking about, which I think works well for dream and kind of dream logic. One thing that I'm excited to see more of is this kind of technology used in like AR games and just kind of in the game space in general. So if you're familiar with some of the architecture of like Pokemon Go, my understanding is that they use S2 as part of their way of dealing with computing in the real world. And so my dream is kind of seeing this as a sort of H3 hex-based hex-based game that everybody is excited about and brings hexagons into the public consciousness. I think that's kind of one of my big dreams for it.
I mean, that's I feel like that kind of use case has been a huge aspiration for a lot of people at Foursquare for many years. I know for Dennis it was. Obviously, we started as kind of a game-ish type of an app. So, and did I think some of those? I think Ingress used Foursquare technology. I could be wrong. I shouldn't come in with out of date references, but I think that's really cool. So Yeah, and what are you guys are working on now? Are there any sort of anything you could share in terms of like, is this being updated? Is this is open source, right? It's available for people to use now. Are there features that are coming out that currently aren't available, that are currently in production or in not in production, I should say, in currently being developed?
So part of this is currently in the open source world, and that's things like H3 and some of these visualization technologies that we've talked about. So those foundational pieces are out in open source, and people can use them today, integrate them today, build things with them now. Some parts of it are still proprietary, so we have this Unfolded Studio offering on top of this that's provides even more advanced visualization, and you can do all sorts of interesting things like flow analysis and flow visualization through that, as well as hex tiles, which is a part of that kind of proprietary package. And of course, we're still working on this, and we're still developing more and more on top of this. That's been a great aspect of Unfolded joining into Foursquare, is we get to continue pushing this technology forward. So some things that are, I'm hoping to see more of is in hex tiles, more analytics functions and more make it easier and more responsive to users. Continue pushing on that, and as well in the in the Unfolded Studio aspect, which I have to admit I'm a little bit less connected to. I'm kind of a little bit more thinking about like, okay, for hex tiles, what can we start adding on top of that now? I think that just in general, we want to see that just be the premier option for working with this Foursquare data and the kind of markets and, you mentioned like footfall and things like this data. The premier way for visualizing that, analyzing that, all sorts of things like that. So there's certainly more and more coming there. You can go look at the changelog on the Unfold Studio docs website, and you just see like every few weeks we're putting out releases there.
Very cool. Well, it's a huge accomplishment to be working on an open source product like this, an open source software like this, and actually have people across the industry using it. So congratulations on that. So we're coming to the end, but maybe you could tell us, where can people learn more, both about this technology and about you? You could, tell us about your stuff.
Sure. So for some of the technology that we were talking about, I think the two biggest links I would give to people, one is unfolded.ai. If you want to learn about Unfolded Studio, if you want to learn about hex tiles, go there. We have pretty good documentation, which should kind of walk you through what's available, what you can do. You can just sign up for free to use Unfolded Studio. So that's a great resource. For H3, it's on GitHub and it's on h3geo.org. So you can learn more about that and get started with using the open source. And then for me, and keeping up to date with what I'm doing, you can find me on LinkedIn, and as well you can find me on Twitter. And I think that they should, or at least the Twitter should be linked to the LinkedIn or something like this. But either way, you're going to find me at Isaac Brodsky.
All right, great. We'll put up on the show notes page as well as anything else that you'll share with us, and maybe we'll get some visualizations up there as well. I think that'd be really cool. Isaac, Absolutely. Thank you so much for coming on the Local Maximum today.
Thank you so much for having me. It's been a great conversation. Happy to be here.
All right. I hope you enjoyed this conversation as much as I did. This is really my kind of thing. I felt like after that conversation, I had to look up R. Buckminster Fuller. That name was just too familiar, not just from college. I think I learned that he invented the geodesic domes, but I feel like he's in a lot of pop culture stuff too. I feel like there was a cartoon I was watching at some point, back when I was young, that had a character based off of R. Buckminster Fuller. So anyway, I found his map of the world that projects the Earth onto an icosahedron. That's what this is now. You project the world onto an icosahedron. So each space is a triangle, but then the triangles get kind of cut up into hexagons with the points being kind of truncated as hexagons. So I will post that on the show notes as well. Of course, he figured out how to arrange the icosahedron so that all of the points go in the water. So that's really interesting stuff. It's a cool map too. I'll post that on the show notes page as well, localmaxradio.com/248. You'll also get links down there of all the visualizations and stuff. And some of these visualizations are really awesome. So I think you'll like that. All right. I'm hoping to have Aaron on next week. We might do a news update, or we might do a deeper dive into the Sleeping Beauty problem from the A.J. Jacobs episode, whichever we're inspired to do. I'm not so sure, but we'll figure it out. Have a great week, everyone. That's the show. To support the Local Maximum, sign up for exclusive content and our online community at maximum.locals.com. The Local Maximum is available wherever podcasts are found. If you want to keep up, remember to subscribe on your podcast app. Also, check out the website with show notes and additional materials at localmaxradio.com. If you want to contact me, the host, send an email to localmaxradio@gmail.com. Have a great week.
Feel the power.